Okay, so good morning. This morning we will be talking about the operations on functions. Just like in operating numbers or constants, we also have four basic operations in functions here. The first one is given by f plus g of x, or the sum of the two functions. Now we can distribute all the terms inside this quantity to the x so that the formula or the form or the general form will be simplified. So f times x, that's f of x. We have the addition here. The operation is addition, so we simply have to copy this one. Now g times x, we have here gx, or g of x. Next is the difference of the two functions. We have f minus g of x, or we can rewrite this as f of x, copy the operation subtraction, and g of x. So f of x minus g of x. Now we also have the other operation. It's f times g of x, or we can rewrite this as f of x, alright, f of x times g of x. Note that in product we can use, or in multiplication we can use other symbols like this one, asterisk, the dot, and even the quantity. Now let's move to the fourth operation in functions, that's f over g of x, or the quotient of two functions, which can be written as f of x divided by g of x. Now to further illustrate this one, let's begin by giving you examples. So starting with the first operation in function, we have f plus g of x, or simply equal to f times x plus g of x. Alright, so let's make an example. Suppose our f of x here is given by 2x squared plus 3, and our g of x is given by 4x cubed plus 1. So we only have to copy the formula and substitute the values of our f of x and g of x. So let's go ahead and write it down here. F of g, or f plus g of x, is equal to f of x plus g of x. So let's go and substitute the value of f of x, that is 2x squared plus 3. Right, 2x squared plus 3. Copy the operation addition. Now substituting the value of g of x, that's 4x cubed plus 1. Do not forget that right after the operation, you have to put quantity first. Okay, quantity of 4x cubed plus 1. Now let's go and simplify this. Copy 2x squared, this is 2x squared plus 3. So we have the operation here and the quantity of 4x cubed plus 1. So just like what we did in the general formulas, we have to distribute the operation to every term inside the quantity. So we have here positive 1. Now after this, we need to combine the like terms and simply copy those terms who do not have the same terms in this particular example. So mag-start kita, or we will be starting with the highest degree or the highest exponent. In this case, we have the highest exponent is 3. So we will write first 4x cubed, followed by the second next, or the second highest exponent, that's 2. We have 2x squared plus 3 plus 1. Now 3 and 1 are both constant. It means they are the same, so we can combine them. We have 3 plus 1, that is 4, and we simply have to copy 4x cubed plus 2x squared plus 4. Now this will be the final answer, or this will be the sum of our two functions. Alright, now let's go ahead and move to the subtraction of function. Suppose that again my function f of x is given by 2x squared plus 3, and my function g of x is given by 4x cubed plus 1. So let's go ahead and try to get the difference of these two functions. The formula is given by f minus g of x is simply equal to f of x minus g of x. Okay, the first step is to substitute f of x, which is equal to 2x squared plus 3. Copy the operation minus quantity g of x, that's 4x cubed plus 1. Alright, let's continue. Copy 2x squared plus 3. Now we have this operation subtraction here in the quantity, so we need to distribute the operation or the negative sign to all the terms inside the parentheses. Negative times 4x cubed, that's negative 4x cubed. Negative times positive 1, that's negative 1 still. So let's go ahead and try to arrange this in descending order. We will be starting with the highest exponent, that's negative 4x cubed, followed by positive 2x squared, and we have positive 3 and negative 1. Now we simply have to copy negative 4x cubed plus 2x squared, 3 minus 1, that is 2. So this will be the difference of your two functions. Negative 4x cubed plus 2x squared plus 2. The rules are almost the same with the addition of two functions. Now let's go and try to have an example for the product of the two functions. Okay, for example, I have here again my f of x is given by the function 2x squared plus 3. And I have here my g of x is given by the function 4x cubed plus 1. So the product of two functions is simply given by f times g of x, which is equal to f of x times g of x. So again, may I remind you, we can have it this one, we can have the dot, we can have the asterisk, and we can have the quantity in giving or in finding the product of the two functions. Now our f of x here, that is 2x squared plus 3 times our g of x, that's 4x cubed plus 1. Now we have here a product of two functions, so we can use the FOIL method. Remember the FOIL method way back in your high school years? F stands for the first terms, O stands for the outer terms or the outside, I stands for the inner terms or the inside, and L stands for the last terms. So in here, we will be starting with F, that's the first terms. So the first terms, we have 2x squared times 4x cubed. This will give us 8x to the fifth power. For a while, we have 8x to the fifth power. Now we have outer term that's given by 2x squared times positive 1. We will have 2x squared. Next, the inner terms. We have 3 times 4x cubed. This will be given by 12x cubed. And we have the last terms, 3 times 1, that is positive 3. Now we need to combine the like terms, or we can arrange this one, or we cannot. That depends on you. But it would be better if we will arrange the sequence of the given terms. So starting with the highest degree exponent, that's 8x to the fifth power, followed by 3, or the second next highest exponent, that is 3. We have 12x cubed, followed by 2x squared, and the constant 3. So this is how we will going to multiply, or to get the product of the two functions. Now let's go and move to the division, or the quotient of two functions. Alright, for example, I have here my f of x. For a while, my f of x is given by the function x squared plus 5x plus 6. And my g of x here is given by the function x plus 2. Now we need to deal, or we need to get the quotient of these two functions. Alright? So let's go ahead and start doing it. So you can simply rewrite this as f of x divided by g of x. So f of x here, that's given by the function x squared plus 5x plus 6, and we have our g of x, that's x squared. So in here, or x plus 1 rather, that x plus 1. If it is already simplified, then we can already stop in here. But if we can still simplify, or we can still reduce this into its simplest form, we can have, or we can factor this out, we can divide this one. Okay, so let's go and start finding the factor of the product, or the factor of the term above. So we have x squared plus 5x plus 6. What could be the factor of x squared? We have x, right? If we will be adding 6 times 1, we will come up with 7. 3 plus 2, we will come up with 5. So we have the factors 3 and 2 here. Now we can have x plus 3 times x plus 2 all over x plus 2. Okay, we can divide this one. Now we are left with x plus 3 times 1, or simply x plus 3. Note that you can also use other methods. We can have the long division and the synthetic division to find the quotient of these two functions. Okay, let's start first with the long division. So we have our dividend, that x squared plus 5x plus 6, and we have our divisor, that is x plus 2. So let's start by dividing x squared with the first term of the dividend. X squared divided by x, or x squared over x, this is simply equal to x. Copy the base and subtract the exponent. So this is 1. We have here 2 minus 1. This will give us x raised to 1 or simply x. Alright, now let's go ahead and write it on top. Again, x squared divided by x, that's x. X times x, that's positive x squared. X times positive 2, that is positive 2x. Now let's go and subtract these terms. X squared minus x squared, this is 0. 5x minus 2x, this is 3x. And note that whenever you see a space, this will automatically be 0. Right after the last term, that's already 0. 6 minus 0, that is simply 6. Now let's divide 3x with x. We will come up with 3. 3 times 3 times x, that's 3x. 3 times 2, that is 6. So let's go and subtract all these terms. That's 0, this is 0, right? And right after the last term and before the first term, that's already 0. So we have 0 minus 0, 3x minus 3x, that's 0, 6 minus 0, that's also 0. So we have no remainder and the answer is x plus 3. Now this is for the long division. Let's have the synthetic division. For the synthetic division, we just simply have to get the numerical coefficients or the numbers of our functions, of our terms. So here, the numerical coefficient of x squared is simply 1, so let's write down 1. The numerical coefficient of 5x is 5, and we have here the numerical coefficient of 6, or this is simply a constant. We have here 6. Now, we will put it like this. Right? And then we have to get our divisor, which is x plus 2. Since we only took the numbers or the numerical coefficient, we also need to find the value of our x. That's x plus 2. So we can equate this to 0 to get the value of x. Now we can subtract 2 to both sides. We have here x plus 2 minus 2 is equal to 0 minus 2. This is x, and we have here our answer 0 minus 2, that's negative 2. Hence, our x is negative 2, so we can write negative 2 in here. Now, we have to bring down 1. 1 times negative 2, that's negative 2. 5 minus 2, that's 3. 3 times negative 2, this is negative 6, and we have no remainder 0. So 1 will be our x, and we have positive 3 in here. The quotient of the two functions is x plus positive 3. Again, in mathematics, there are many ways to kill a cat, so whatever method we will be using, we will come up with the same result. We use factoring, so we have the result x plus 3. We use the long division, the result is still x plus 3, and we have the synthetic division, still the result is x plus 3. Now let's go and prove to the different compositions of functions. Right, composition of functions. So what do we mean by composition of functions? This simply means substituting, alright, substituting or to substitute one function to another, right? To substitute one function to another. Now we have different kinds of compositions of functions. We can have the f composition of g, well, the f composition of g, or we can rewrite this as f of g, f of g of x. And we also have the g composition of f or we can have it written as g of f of x. And we can also have the f composition of f, or it can be written as the f of x. So in here, in the first one, we have the f composition of g. This means that our g of x will be substituted to f of x. So the g of x is the domain, or the domain of f of x. And the second one, g composition of f. So f of x will be substituted to g of x, and f of x is the domain of g of x. We have the next composition, f of x. So f of x will be substituted to itself, and the domain is itself as well. Okay, so let's go and try to have or to look for these compositions. Let's start with the f composition of g. So suppose that I have here my f of x is given by the function 2x squared plus 3. My g of x is given by the function 4x cubed plus 1. So let's start with the f composition of g, or simply f of g of x, right? So our function of f, that is 2x squared plus 3. We will substitute g of x, or simply 4x cubed plus 1, to our x variable in the function f of x. So let's copy 2, and then x, this will become 4x cubed plus 1, copy the exponent, the operation, and the last term 3. Now we have here our 4x cubed plus 1 squared. We have to use the FOIL method. Okay, 4x cubed plus 1. So this will give us the first terms, that's 16x to the 6th power. The outside terms, that's 4x cubed. The inside terms, that's still 4x cubed. And the last terms, that is positive 1. So we have 16x to the 6th power plus 8x cubed plus 1. Now we have copied 2, and 4x cubed plus 1 squared becomes 16x to the 6th power plus 8x cubed plus 1 plus 3. So let's go and distribute 2 to all the terms inside the parenthesis of the quantity. So this is 16x to this, 16 times 2, this is 32x to the 6th power. 2 times positive 8x cubed, this is 16x cubed. And we have 2 times positive 1, this is positive 2, plus the last term 3. Now let's combine the like terms and copy those terms who do not have a similar term. We have 32x cubed plus 16x cubed. Wait, so this is 32x to the 6th power, rather, plus 16x cubed plus 5. Now this will be the final composition of your function. Right. Now let's go and have the g composition of f. Suppose that my f of x is given by the same value, by the same function for x minus 5. My g of x is given by x squared plus 4. So let's find the g composition of f, or simply g of f of x. So in this case, f of x will be substituted to g of x. That means for x minus 5, will be substituted to the x of g of x. So our g of x, that's x squared plus 4. Now we will change x squared into 4x minus 5. Copy the exponent and the rest of the terms. Now we need to use FOIL method. 4x squared minus 5 can be written also as 4x minus 5 times 4x minus 5 plus 4. So we have in here 4x minus 5. Let's go and use the FOIL method. That's the first terms. We have 16x squared. The outside terms, that's negative 20x. The inside terms or the inner terms, that's also negative 20x. And we have the last terms, negative 5 times negative 5, that is positive 25 plus 4. Now let's combine the like terms and copy those terms that do not have the same or the similar terms. This is 16x squared. We have negative 20x minus 20x, that's negative 40x. Positive 25 plus 4, that is positive 29. So this will be your new composition of the function. Now, what if we go and look for the f of x given the same function f of x, which is equal to 2x squared plus 3, and g of x is equal to 4x cubed plus 1. So in this case, we will look for the f composition of f, or simply f of x. Okay, this means that 2x squared plus 3 will be substituted to x in itself. So that is 2x squared plus 3. We have 2 times our x, that becomes itself 2x squared plus 3. Don't forget to copy the exponent and the rest of the terms. Now we'll be using FOIL method again. 2x squared plus 3 times 2x squared plus 3. This will give us 4x to the 4th power. Alright, and we have that is 6x squared plus 6x squared plus 9. We have here 4x to the 4th power plus 12x squared plus 9. So that's 2 times 4x to the 4th power, right, plus 12x squared plus 9 plus 3. Now let's distribute 2 to every term inside the quantity. 2 times 4x to the 4th power, that's 8x, right? 8x to the 4th power. 2 times 12x squared, that is 24x squared. 2 times 9, that is positive 18 plus 3 in here. Now let's copy 8x to the 4th power, positive 24x squared, and 18 plus 3, that is 21. So this will be your final answer. Now that ends the lesson for operation and the composition of functions. I hope you guys enjoyed and learned, so goodbye.